Hello, I would like to remind you to ask questions at the end of the presentation. Our next presenter works as a messaging architect in the Deutsche Boerse. His name is Jakub Scholz. Please invite him.
Hello, everyone. This talk is in the IoT stream, but I hope you won't be too disappointed that my background is actually not IoT but finance. I work for Deutsche Boerse. That's one of the world's leading exchange market operators. We run several stock and derivative exchanges. We have our own clearing house. We run services in settlement and custody. And in the last years, I spent the time building interfaces based on the AMQP protocol. And that's not only interfaces which connect our own applications, but also interfaces which connect us with our customers who write their own applications. I think that's not that usual, and that's why I would like to share the experience we made, what we learned, and then discuss it with you. Before I start with the first slide, let me ask you, how many of you know what message-oriented middleware is? And how many of you know AMQP? Okay, that's quite a lot more than I expected, I have to say. I'm glad to see that. So let's start. In finance, the IT is not really that different from the other areas. We have usually some server which we run, and then we have some customers who run their own applications which are communicating with our server and do some transactions, exchange information. In the past, we did it usually in the way that we had some libraries which we provided to the customers as the API, and the customers use them in their own applications. And the protocol between the library and the server was usually something proprietary, not really well documented, not really opened. So, can someone see what's wrong with this approach? It's basically, with the library API, you as a service provider are intruding into the space which does not belong to you. You ship some library which has to be installed by your customer, so they usually don't have really free choice of operating system. They don't have free choice of hardware. They often have no choice of programming language or choice of programming style. And since it's your software running with your customers, then you need to provide a lot of support. When the customer calls and says, look, the library is not working for me, you have to deal with the facts, which operating system is he using, which patches did he install. And that can be very complicated, especially when it's not your computers, you have no access to these computers. So lately, we are switching more towards protocol-based API. So what does change with the protocol API? The API is not anymore the library as it used to be, but the API is the protocol. And the library and the client application is full responsibility of the customer. So as you can see from the picture, the separation between the service provider and the client is now much more clear. And this may sound on a first look like if you offload more work onto your customers, who then have to write the library, test it, support it on their own. But if you choose a good protocol for the API, then maybe they don't have to do it, because maybe there are many different libraries available on the market, and they just take one of them, they choose the operating system, programming language, whatever they want, and they just develop it accordingly. And because no software is running on the customer side which you provided, that frees you from a lot of the support activity, because it's the customer software and the customer knows the software because they wrote it and they can support it themselves.
I have a question.
Yeah? I would eventually get to it at the end. In reality, it's of course not that there's no support activity which you have to do. So at the end, it's your customers, and if you want to keep them happy, then, okay, sorry, to repeat the question. So the question was whether it happened that the customers called to us and complained that their library is buggy and complained that the protocol is wrong and not working. So this definitely happens, and if you want to have happy customers, then you have to deal with it somehow, but it happens a lot less than when we really shipped the libraries to the customers. And later during the slides, I will get into more details what to do so that these situations don't happen too often.
So in the end, you have to work with your customers to find out if the problem is in the library or in your API. Right.
At the end, if they reach out to you, then yes, you have to work together. It differs a lot customer to customer. Some customers don't call us at all. Some call us very often with, let's say, simple questions which they might be able to answer themselves. So I mentioned that with a good protocol, this protocol API might not necessarily mean that you are just offloading work onto your customers. So what makes a good protocol? There are many, many different technical things which you can use to define a good protocol. You can talk about performance, throughput, latency, reliability. What was important for us and what's important for the protocol APIs is the openness of the protocol. And that's why we have chosen AMQP as the protocol of our choice. AMQP has quite a lot of history. It was created as a kind of common project between IT companies and financial companies. But, and that's why this talk is in the IoT stream. Today, it's very valid also for the Internet of Things. There are some older versions of the protocol, in particular the 09 and 091, which is basically a synonym for RabbitMQ. It has quite a huge community. If you search on GitHub for AMQP, I'm pretty sure most of the results will be for RabbitMQ. But it's still basically one product, one community. The same applies to the 010 version of the protocol, which is actually where we started some years ago. The 010 is implemented in the Apache Qpid project, eventually sold as Red Hat MRG Messaging by Red Hat. But again, although it has a good community, it's still just one community. And that's what's different with the AMQP 1.0. And if you start today, that's what I would recommend to you. Because with AMQP 1.0, you don't have anymore one community, but you have much bigger ecosystem. It's not only Apache or Red Hat who implements AMQP 1.0, but already today you have working products from Microsoft, IBM, but also from some smaller companies. So you have much bigger choice. And if we talk about openness, it's approved as ISO standard, and you probably can do much better in terms of open standards than having an ISO standard. But just by choosing the protocol, that doesn't really create the protocol APIs, because the protocol is just mean how to do it, but it's not the API itself. So what do you need to do to specify the protocol API? You need to clarify network, security. You need to specify how to send or receive messages, and many more things, including documentation and support. So let's start with the network. AMQP is usually running over TCP, so you can basically use the public internet infrastructure, and if you would use it for Internet of Things, then that would be probably your choice. In Deutsche Boerse, we are using usually VPNs and lease lines, which give us more performance, security, and stability. But they can get also expensive, and they are not really suitable for everyone. Also, if you want the API to be used directly from web browsers, you should definitely consider WebSocket support. The binding between AMQP and WebSockets is slowly getting more and more final in the OASIS committees which are standardizing it. And that allows you to write applications which talk AMQP directly in the browsers using JavaScript. A bit with the network related is encryption. AMQP supports both TLS over AMQP as well as AMQP over TLS. The second one seems to be the usual choice. So you open the normal TCP connection. On top of it, you establish the TLS channel, and only then you open the AMQP connection. I would say security encryption today, it's something what should be considered as mandatory, but which versions of SSL or TLS protocols should you support, which cipher suits? Lately, there were a lot of different issues with some of the versions, some security problems. When you start from scratch, it's very easy to select only the versions which are still considered secure, which are the latest versions, and that's very easy. But over the time, if you are running the API for several years, it gets more and more complicated. So our oldest API, I think it's running over 6 years now, and some of the clients who were wrote on the beginning by our customers are still running there, and they are actually still working. And every time when you update the TLS configuration and decide that you will not support some older versions, you risk that some of these old clients, which are maybe running on some operating systems which are not really updated since years, might not be able to connect. So it's always a bit of trade-off between the security and between the compatibility with the customers. Depending on your data, the security should probably win at the end, but it's important that you don't stop supporting SSL 3.0 just from scratch from tomorrow, but that you discuss it with your customers and give them some time to test and prepare their applications. Once the TLS channel is established, the AMQP connection can be opened, and the client can do the authentication. AMQP supports SASL, that's a simple authentication and security layer, which gives you many different options. You can start with something as simple as username, password, but you can use Kerberos, or as we do, you can use TLS client authentication, which is done based on the SSL certificates. You should be aware that the more unusual mechanisms you select to use, the higher there is the probability that some of the clients around there will not really support it and will not work with your API. Basically, username and password is supported by every client, but with the other mechanisms, it gets more and more complicated. In Deutsche Boerse, we are using the SSL client authentication. That basically means that the identity of the user is taken out from the TLS channel and is established based on the certificate used when opening the connection. So basically, the username is usually constructed based on the subject of the certificate. Well, but that's still not everything. You can use different ways how to authenticate the client. The usual way on the normal internet is to use the public certification authorities. That basically means that you don't say exactly which clients you trust, but you leave this to a certification authority which you trust. That can lead to a lot of different complications, mainly because, as I said, the username is the subject of the certificate. And your view on who the user is usually not the same view as VeriSign has. So you view your customer maybe under some customer ID, or you gave him some username. For example, we have something what we call member ID, which is a 5-character code, which identifies every customer. But that's not something what's known to the certification authority. So they will not issue a certificate which is based on this identification which we are using. So that's not that great option. On the other end of the spectrum are self-signed certificates, which is actually what we decided to use and what we are still using. The self-signed certificates have the advantage that you tell your customers, generate a self-signed certificate and provide us in a secure way with the public key. And because they are generating the certificate and signing it on their own, if you tell them, use this as the subject in the certificate, they will simply do it, and you have in the subject exactly the username which you need. But that still doesn't solve the main problem because it brings together another issues. One, if you say self-signed certificates, for a lot of people that means unsecure, which maybe is not necessarily true, but you want your customers to use your API, so you either have to convince them or we have to do something else. Other problem with the self-signed certificates is that it was one of the things which was not really supported in all the different clients. So during the years, we spent a lot of effort either on our own to implement the support in the different clients or to push companies like Red Hat to implement this in their clients. And last but not least, the problem is not only in the clients, the problem is also in the messaging brokers. Because currently we are still using the merge messaging broker, which is based on Apache Cupid. And that has a great support for using the self-signed certificates. But if you decide to use ActiveMQ, there the support is not that great anymore. I'm not sure you can really do it as easily as with merge messaging. So I wonder, is there some third way which might work better? And to be honest, if I would be starting some new API today, I would probably try to use private certification authority, where you run your own certification authority. Your customers don't sign their certificates on their own, but they send them to you so that you can sign them. You still get the advantages of the self-signed certificates, that you can define the usernames, but it's not public CAs, so it still doesn't always sound as something what should be trusted, especially if you are dealing with some banks and financial institutions. Another point maybe in the Internet of Things, using public CA can get probably very expensive if you have separate certificate for every client. So that was the authentication. Authorization, it's something what should be on the API as well. I won't talk too much detail about authorization. You should use the principle of least privilege, so you should give every user only those rights which it really needs. But I would talk more about different resource limits, because that's what's missing in many of the messaging servers, and that's what can make your life more complicated or more easier depending on the support. Imagine that you are running some service, you have some customers connecting, and some hacker takes down your server and the customers cannot use it anymore. That's a bad situation. But it's even much worse if it's some developer somewhere on the other end of the world who is writing a new application, it's developing it against your production system, then starts half-finished application and goes for lunch. The application is maybe creating more and more temporary queues until your server runs out of memory and dies. And that's something where the limits can help. So if the messaging server supports it, you should definitely set all the different limits for maximum number of connections, maximum number of sessions, maximum number of temporary queues, maximum message size, maximum message rate. Everything what's possible should be limited. Now, with all the basic stuff in place, the clients can start sending or receiving messages. So the entry points are basically the structure of your queues or topics which you are using to deliver them. We kind of learned several rules which help us make better interfaces if we follow them, or maybe the other way around. By not following these rules, we made bad experiences. The structure of the queues and topics is usually very hard to change once you have hundreds of clients running somewhere and connecting to it. So that's something what you should very carefully think about before you really have the first release of your API and let the customers connect to it. Another thing with which we made a good experience is that every user should have its own namespace in the queues and in the topics. So maybe start every queue name with the name of the customer, because that helps very much when you are analyzing some problems or when your operation teams are running the API. Yeah?
By user here, do you mean an actual user, like an end user, or do you mean the project or the customer?
So the question was whether with user, whether it's meant the actual customer end user or the project. So here, I mean definitely the end user, but you can interpret it in your own way who the end user is. So in most of our interfaces, the end user is the company which we are talking with, and not really the individual, the person which is using the application which is connected to the API. Together with the namespaces, another very useful rule is that you should definitely not use any anonymous objects. So something like tempq123456 doesn't help you when you are operating the system or when you are analyzing some issues in the logs, because you have no idea who does this queue belong to, who created it, and so on. And another useful rule is that you should always create rather more queues than less, because in the clients which the customers will write, it's usually much easier to write more receivers to receive from 10 different queues than to receive from single queue only 10% of the messages, maybe based on some binary payload which is inside the message. You have to be aware that not every question has a yes-no answer. So the APIs don't always work in a simple request-response way. That's what looks nice in the simple examples, but very often you need to create some workflows which include multiple different requests and responses, or maybe which include even multiple parties. So one customer requests something, the server acknowledges the request, then asks another customer whether he approves this transaction, and only when this other customer approves the transaction is actually completed and entered into the system. And all these workflows need to be properly documented. Yeah? So the question was whether some metadata can be associated with the queue to identify the user. I would say that's not really part of the AMQP protocol. Okay. So within the protocol, you of course know which user created the queue, right, but it's not always obvious from the software. And the way how you can do it, that's then a bit specific to the implementation. So the Apache Cupid or Apache ActiveMQ, I think they have something called queue policies, which allow you to the temporary queues be automatically named using some patterns, which then might help in these situations, so that the random names are not created like this, but that they follow some schema.
So it's really important to make sure your queue names are meaningful and have enough information to them.
Yes.
So the second one is create more rather than less queues. I mean, is there some sort of upper limit to the number of queues that you can create or have going simultaneously, or do you have to worry about that in practice?
Okay, so the question was whether there is some limit how many queues can be created. I would say again that's specific to the implementation which you are using. So on the Apache Cupid, it's definitely no problem to have thousands and thousands of queues. It of course a bit depends how many customers you have or how many connected clients. Let's say that our interfaces have usually hundreds of customers. If you, for example, implement a smart toothbrush and sell it to millions of people and all these toothbrushes send some messages to you, then you probably cannot afford to open many, many queues. Then in that case, maybe you can help with something else. Most of the implementations support some sort of filtering when reading from the queues. But the filtering is easy against some headers or some application properties, but the filtering is very hard against the message payload, which might be some binary data or some complicated XML. So by using some application properties to distinguish the different types of messages, it's much easier to use only single queue, but for the clients to use the filters on the messaging server to get only selected messages. Yeah? Okay, so I will try to repeat the question. I hope I will get it right. So the question was whether using the namespaces with many different users and with, for example, 5-character codes identifying the users, whether it just doesn't create more chaos. So a lot of the problems are, at least in our case, a lot of the problems are not really discovered by our teams who are operating the API. But a lot of the problems are a customer calls the customer support and says, look, this is not working for me. And then when you have really the names in the queues, it's much easier for you to find the queues used by this customer and to see, are they full of messages, are the queues empty, is someone connected to the queue? Might be, let's say that in our business, there are not that many potential customers. So maybe that's a bit easier for us. So let's talk for a moment about the message payload. AMQP has its own type system, or at least each version has kind of its own type system. Which is great and supports a lot of stuff, but it's unique for AMQP. So you can use this type system to encode the message bodies, but then you might not be really free to decide, okay, let's use also MQTT as the alternative protocol, or let's use WebSphere MQ as a alternative for connectivity, because these you would basically need to transform these payloads into something else, because some MQTT client will not be able to decode the AMQP payloads. Luckily, you can very easily use text or some binary data as a payload in the AMQP messages, so you can choose whether you want to use XML or JSON, or whether you want to use, for example, something like Google Protocol buffers or BSON. You should be aware that human readable formats might be intriguing because it's easier to analyze all the problems, but AMQP itself has no built-in compression currently. So if you use something like XML, which is very verbose, then you will get the big messages and you need a lot of bandwidth. So maybe using some binary formats will be better for you. It's also when you are transferring a lot of numbers, which is what we usually do, decoding these numbers from the text formats into some floats is quite intensive on the resources, on the hardware resources. That's, again, a lot easier if you have binary encodings. And there's a lot more than just these things. We talked a bit about it on the beginning. How does it work when the libraries are not good enough? The first problem which you will run into is that the documentation of the different open source libraries is not good enough. There are usually many different code examples, but they are simply too primitive. So if they contain some authentication, it's always username password-based authentication. They are often just showing how to send one message, but they don't show you how send or receive 1,000 messages in very fast pace. Also, they usually contain just some hello world content and not the real binary data which you want to send over the protocol. So at the end, you will always need to create some programming documentation and prepare some code examples so that your customers know how to use the different clients. And over the time, you will definitely see many negative use cases, so things which some of your customers did and which didn't work really well. And that's another thing which is very useful for documentation purposes. Unfortunately, I'm saying here that the open source projects usually lack proper documentation and examples. And I have to say, we wrote our own documentation and examples, but didn't really manage to commit it back to the projects, which is unfortunate, and I should definitely find some time for it. Another problem which you may run into is the compatibility. So on paper, it's everything perfect. You have a client from vendor A, which supports AMQP 1.0. You have a server from vendor B, which supports AMQP 1.0. And the standard is ISO standard, so what can go wrong? I was actually positively surprised that we really have clients which were not updated for the last 6 years, which are still able to connect against the latest versions of the messaging broker. I, on the beginning, expected that the compatibility would be much worse, but it's still great if you can find some time to test all the different clients, make sure that they work somehow, at least with some basic tests against your APIs, that they can authenticate, that they pass the authorization, and then you can create some compatibility lists so that your clients know what's compatible and what's not. Yeah?
Do you still have to support AMQP 0.10 in a mixed environment with AMQP 1.0?
So the question was whether we still have to support AMQP 0.10. And the answer is yes. We are still running most of our installations on the merge messaging software, which supports both 0.10 and 1.0. And we are basically now in the process of getting the customers to the AMQP 1.0 so that eventually, once everyone is there, we can kind of cut off the support for the old protocol and maybe to move to some newer applications.
So it is like a rolling upgrade path. You can upgrade.
That's,
you don't have to upgrade every time.
That's one of the advantages of the merge messaging or Apache Cupid project, that it provides you a clear migration path to the 1.0 protocol. You don't have to say, okay, tomorrow I will stop supporting AMQP 10 and start supporting only AMQP 1.0.
Can I have a question?
Yeah.
Do you use some abstraction layer on top of like those two versions of MQP protocol, or do you have like completely separate implementations of your API
Okay, so the question was whether we have separate versions of the 1.0 or 0.10 APIs, or whether we have some abstraction layer to make basically the same thing work with both at the same time.
Just one implementation, and you just expose it in different versions of the product.
Yes, so in the Apache Cupid or merge messaging broker, there are simply some queues or an AMQP exchanges which are coming from the 0.10 world. And once you enable the 1.0 protocol, you can have access to the same queues. So we didn't really change the queues or the exchanges and the topics at all. We basically just let the users access them over the new protocol. So at the end, it's just one API for us.
So the broker does all the magic for you, basically?
Yes, the broker does all the magic. It translates the messages from 1.0 to 0.10 and vice versa. Another thing which is useful for the compatibility is to test the upcoming releases. It's always easier if you manage to find out that the new release of the Cupid Proton client doesn't work with your interface, and maybe get it fixed before the release, because once it's released, then you will get into the problem that your customers download the latest version, start developing some application, then they found out that it's not running. And that can be avoided if you test the upcoming releases when they are in beta or release candidates. Question?
Do you have any setup with your customers where they participate in the testing?
Yes. So the question was whether we have some setup where the customers can participate in the testing. We have something what we call simulation environment, which is basically identical to our production environment. It's operated by the same team. And that's what the customers or their vendors who are developing the applications for them can use as a sandbox for testing. So when we do some upgrade, we always do it in this simulation environment, and only a few weeks later we do it in the production to give everyone time to adjust. For the end, maybe as a inspiration, one of the interfaces which we have is called Eurex Clearing FixML interface, and it connects one of our subsidiaries, Eurex Clearing, with its customers. So the clients on the other end connecting to us are all the different major banks, funds who are using our exchanges. As I said, it supports the 0.10 and 1.0 protocols. Additionally to that, we have as a connection alternative IBM WebSphere MQ, because when we started with it, some of our customers who have a lot of WebSphere MQ installations insisted that we have to use WebSphere MQ. On the beginning, it was a lot of them, but during the time, most of them found out that the AMQP is very easy to use and that it's not as unreliable, unstable as they were afraid on the beginning. And I think we have only single-digit number of customers who are actually using the WebSphere MQ connectivity. And all the documentation to this interface is public, so if you want, you can have a look at it. There are some programming guides with the code examples in different languages and so on. And that's it. So if you have any further questions, yeah?
You mentioned earlier that you can connect to a more general queue and then apply filtering, and I was wondering whether the actual filtering workflow is taking place on the server or on the client side.
The AMQP 0.10, just to repeat the question was whether the filtering of the messages is done on the server side or on the client side. On the 0.10 protocol, there was no support for filtering on the server. So usually, if there was some filtering, then it was on the client side. That's much better on the 1.0 version, where the filtering support is kind of built into the protocol. So I think all of the 1.0 implementations, when creating a receiver from the queue, you can basically specify your filter, and then the broker automatically gives you only the messages matching the filter. It then depends a bit on the product, which exact filters are supported or not. It's usually quite easy if you want to filter based on some application headers, but it gets much more complicated if you want to filter based on some binary payload or even XML payload.
That's all time we had for this presentation. Thank you, Jakub.
So if anyone has any further questions, I will be around so you can ask. And those who ask the questions, they can pick up the scarves here.